Good evening, all of you. Welcome to the 25th webinar in the Thursday webinar series of IEEE Malabar Subsection. So as all of you are aware, from June 1st onwards, IEEE Malabar Subsection is having a Thursday webinar series. Hello, yeah. This is our 25th webinar, and today we have an excellent speaker, Professor Samson Mathew, who is actually a former Dean of NIT Trichy, and currently he is the Director of NATPAC. So the topic he has given is future vision to improve safety and efficiency of transport using ITS. I'm sure it is going to be a wonderful talk, which all of you will get benefited. He will touch upon the latest technology used in transportation systems. So this webinar will be anchored by Dr. Sabik PV. Over to Dr. Sabik for introducing Dr. Samson Mathew.
Thank you, sir. Good evening, everyone. Today we have Dr. Samson Mathew with us. He has completed his BTech degree from University of Kerala in the year 1985, MTech degree from University of Calicut in 1988, and PhD from University of Calicut in 1996. He received the Young Scientist Award for the year 1994. And Dr. Samson handled various positions like Dean Students Welfare, Head of Department Civil Engineering, Head Center of Excellence in Transportation Engineering, Chief Warden, Associate Dean, Planning and Development, etc. at National Institute of Technology, Tiruchirappalli, formerly known as Regional Engineering College, Tiruchirappalli. His teaching and research area includes transportation planning, traffic engineering, road safety, pavement management, and ITS. He has guided 83 postgraduate thesis works in various fields. Under his guidance, more than 13 scholars have completed PhD. He has published more than 40 papers in international and national journals, 30 papers in international conference, and more than 70 papers in national level conference. He has successfully completed several projects sponsored by Ministry of Human Resource Development, Government of India, National Rural Road Development Agency, Coir Board, etc. This total cost worth around 1 crore projects. He is a member of State Technical Agency of Prime Minister Gram Sadak Yojana program for Tamil Nadu and Pondicherry. He is also actively involved in transportation related consultancy work. Currently, he is working as Director NATPAC. So welcome you, sir, for this webinar. And we, on behalf of IEEE Malabar Subsection, we welcome you. Over to you, sir.
Thank you, Dr. Sabik and Dr. Madhukumar. I'm happy to associate with the IEEE the lecture series or webinar series. I'm very happy that you have organized. This is the 25th. That means during COVID time, the IEEE Malabar session was very active. That's why so many programs you could organize. So I'm honored that listening. I was also invited, and thank you, Dr. Madhu, for the invitation. And I just wanted to share some of my experience with the ITS. Maybe we have started some projects in the year 2002. During that time, the ITS development in India, that was only in the beginning, and later probably in 2008 time, I went to Singapore to see the ITS development in other developed countries. So, from the from 2000 or 2002 till today, if you see, now every day or every hour, the developments are taking place in the field of ITS. So I just wanted to restrict my talk to the future to improve safety and efficiency of transport using ITS. So that is the topic. If you see this photograph, you can see that it's a expressway, not a grid that lesson not in India, and you can see that one. It is an 8-lane road, and how the vehicle movement is taking place. At the same time, of course, this is an Indian condition, not recently. It was the case in Delhi long time back, and you can see the mix of traffic which we have to handle from the small vehicle like a cycle to a big vehicle like a bus or a train, etc. And it's again the composition of traffic. You can see in developed countries or other the developing countries, some cases you have only limited number of categories of vehicles, maybe the four-wheeler or buses or heavy vehicles, or very rarely probably you can see the two-wheeler. But we should accept the fact that in Indian condition, we may have to accommodate all these types of vehicles, including the bullock cart in some maybe urban areas or even the rural area you may have to consider. But beyond that, and if you look the way how we should compare disciplined or like a developed country, in which you can see the how the road traffic or the road users, how they are disciplined and how they are maintaining their lane. And of course, in Indian condition, you can see that one. This is the situation now, the right hand side photo, and even this become a theory in such a way that how like densely we can accommodate the vehicles in a limited space. So this is a best example, and this is probably you can see that one in the like in urban centers. While coming to the public transport systems, public transport system on the left hand side, you can see the developed countries in which you have the bus of different categories, or maybe the truck, train, or tram, etc. of different categories. But on the other side, we may have to like move people in different like risky positions. Maybe the connection to the rural area may be very limited, and they may have to like try all these risky like the positions. And you can compare, the pedestrians and cyclists. They were given proper lanes, and how nicely this pedestrian and the cycle paths are like maintained, or that like how it is provided. But on the other side, when though we may have the pedestrian facilities, sometimes you may have to like you can see that when the pedestrians has to negotiate with the difficult the payment conditions, and even the like sometimes the two-wheelers also will be using that spaces. And you can see the parking is a big issue in Indian or Indian urban or the town centers, and the vehicles are parked on the streets where these vehicles are meant for the streets are meant for the moving vehicles. And you can see that when the parked vehicles and sometimes the enforcement will become a problem, or you may have to go for a multi-story parking facilities as experienced in developed countries. With all those things, the comparison we are like the developing country, and economic conditions are increasing at a very fast like pace, and urbanization is a fact, and we are expecting that, let's say, more than 50% of the population in the near future will be staying in the urban centers, and maybe we have new cities or new urban centers or new smart cities are coming. We have all these issues, and with this urbanization or the increased population in cities or the other things and all, you can see that one traffic congestion is one difficulty with our Indian like roads are facing, especially the urban roads. So the reason for that one is there is not sufficient road development. Of course, we might not have the space for the road development or the growing number of vehicles, especially with the COVID pandemic. You can see that when the individual vehicles numbers are increased in our streets. You have a low speed because of the more like the vehicles on the street. You can see that when the congestion is the issue, and that congestion will make that speed to a, or force that speed to a lower level, and that, like, this congestion and the speed restrictions may increase the accidents and more fatalities you have to face. Then fuel consumption, increased pollution, all those things are issues. And it is a fact that it is not possible to build enough new roads to meet the demand. So we may have to explore the concept of highway system, or like a smart highway systems, and the vehicles as integrated systems of the highway. And that today's topic, I just wanted to concentrate or more emphasis I want to give it to the road safety challenges. So why the ITS is required? So India is going through a period of drastic change in the transportation. You can see that when transportation infrastructures are improving, and or like the total the length of the network is increasing, and you can see that vehicle population is also increasing. We should accept the fact that the economy is growing, and that too at a very rapid the speed. Insufficient and inadequate public transport system is an issue in Indian condition. We are not in a position to provide sufficient public transport, safe, efficient public transport system to the society, and because of that one, the vehicle ownership levels are increasing. So maybe the one balancing like a management strategy which we can try is to balance the supply and demand. So the supply strategies and the demand strategies, in which supply by considering the existing the supply, how the demand can be reduced. So that is our strategy. So supply strategy is coming, development of new facilities like new roads or new transit lanes, or be widened, but there is a limit for that one in cities and all. You cannot you cannot widen the road beyond certain limit, or existing facility by providing additional lane, increase the capacity of public transit system so that the private vehicles can be reduced. We can move the people from the private vehicle to the public transport system. Capability or efficiency improvement of existing facilities means improved traffic control measures, uninterrupted flow of traffic, or through grade separated intersections. But these are all limitations are there. You have a the expansion can be only to certain level. Only beyond that one, the expansion is impossible. In that case, probably you can reduce the demand, or the demand the strategies you can reduce that demand in such a way that through implementing the road pricing. You suppose if you want to use the road, you have to pay. So in that case, people will try to avoid to use the road. They will try to use the transport facilities, maybe the train or the metro or light rail transport systems, or sometimes the bus, etc. You increase the parking fees in the cities so that the people will try to restrict the use of private vehicle. You give incentives to the carpools. Like 3 people are going in 3 different cars individually. They can be pulled together to use a single vehicle, and you give some incentives. High occupational vehicles or the buses or similar facilities, public transport usage, you can improve these things by providing some incentives. Then improvements in bicycle and pedestrian facilities, so that the congestion, they can be given separate pedestrian facilities, separate bicycle facilities, so that the number of vehicle users on the road can be reduced. Or another demand strategy is to start working hours. Maybe the school can start a bit early. The working of the office hours can start later. Schools can close early, or you can have even the different. The offices can work at different time periods. Like that, you can the demand strategies. But in all those cases, there you have a limitation beyond that one, beyond certain limit, you cannot do these things. So in that situation, probably the intelligent transportation system, short form we'll call that one as ITS, is the application of computer, electronics, communication technologies, and management strategies in an integrated manner to provide travel information so as to enhance the safety, reliability, and efficiency of the transportation system. So this is the like a conventional definition for this ITS, in which you have the terminologies like computer, electronics, communication technologies, management is there, then integration of all these things to the communication, the travel information system. Finally, looking to enhance the safety, reliability, and efficiency of the transportation system. So, in our National Urban Transport Policy, which was published in 2014, encourages adoption of ITS technologies in the field of transportation to augment the facilities provided. Probably you would have noticed that one in our the smart cities or the cities and all. I guess part of that one recently. It was inaugurated in the Cochin area, or like it is coming up in Trivandrum, and wherever this smart cities are coming, this ITS became a part of that smart city, so that became a model and it can be extended to other cities also. What are the advantages of this ITS? It is giving an improved mobility, like throughput, the travel time can be reduced, increased safety through ITS, the crashes, the number can be reduced. Environmental benefits, I mentioned that one, the reduction in emissions, pollution in the form of atmospheric pollutions, sound, etc. Incident response and recovery, informed trip making, better way to manage congestion, better utilization of roadway capacity, like through corridor or the network, maybe the management, through ITS technology. And finally, all those things, all the above benefits will lead to the economic growth. In a way, the productivity and sustainability will be improved. So that is the benefits of ITS. So if you see the share of these benefits, you can see that one. Accident cost savings will be the maximum. Definitely the time savings you are getting, that is the next one. So the accident cost savings and time savings will contribute the maximum share. You can see that when the fuel and emissions will be reduced, the savings will be there. Operating costs will be reduced by an improved managed way, and the government cost savings is also there. So you can see that one, the the savings you are getting in terms of accident cost savings and the time savings. So why ITS? So it will give you a systematic problem solving approach, acknowledge the rapid changing travel behavior. You can see that one, the travel behavior is changing, its pattern and its information impact. The best example you can see after the COVID, the beginning, like lockdown and all, how the travel behavior changed and how the travel pattern is changed, and what will have this effect on the travel demand and the road network. Seek for faster, easier, better, and safer travel. So that is the fundamental basic the objectives of the transportation system. It should provide a fast, easy, better, and safe travel, whether it is passenger or goods. You have an opportunity for revolutionary and integrated rethinking of urban and regional transportation planning. So the ITS for road safety will be coming under advanced driver assistance system, advanced vehicle control and safety system, emergency management system, advanced travel information system, intelligent speed adaptation, pedestrian detection and warning system, speed or red light violation detection system, ignition locking system like alcohol or non-helmet detection system, helmet or seat belt or wrong side driving, and adaptive headlights. Maybe some of these things you would have experienced, and some technologies or the ITS technologies are coming up, and some of the existing systems it is improving. So in a way, this ITS become a part of the common man's daily life. So I will be sharing some of the the examples of these technologies. Coming to the ITS architecture, because it's the IEEE the forum. Probably travel is one part. You may have the other the ITS the centers where this ITS is functioning, where the traffic management, emergency management, toll administration, commercial vehicle administration, maintenance and construction management, information service provider, emissions management, transit management, fleet and flight management, management, etc., etc. So these centers you can add more number. You can add. So it can be from fixed to fixed point communication, or maybe fixed to single to multi. All combinations you can expect. And you have a dedicated short range communications in roadways, security monitoring, toll collection, parking management, commercial vehicle. These are all application set that is coming. Then it is there in the vehicle also, vehicle to vehicle communications or vehicle to infrastructure communication system, construction of vehicle, transit vehicle, commercial vehicle, emergency vehicle, and the vehicle itself. You can see that ITS architecture is there. So wherever the traveler is coming, all these the centers, field, and the vehicle, it is functioning. So that is the ITS architecture. And coming to the ITS information chain, you can see that one transportation system data is collected through different the sources. Data is processed, and the information is available, and information is distributed directly to the ITS users, or information utilization, it will be further processed, and then it will be coming to the ITS users. And this figure shows the network, the communication, and the flow or the movement. You like in a city, different locations, different places, the vehicle infrastructure or the tower, the satellites, All those things are collecting the data and communicating the data, and they are sharing the data. So the data collection part, when it are coming, data collection part, you have different technologies to get the data, and our idea is to collect the data through different sources, and the real-time data is important. And when it was started, the ITS development started, we were collecting the data only through offline. Now you have a mechanism to collect the data through online mechanism. You may require the vehicle dimensions, that nothing but the vehicle type, the speed, lane occupancy, flow rate, etc., etc. All these traffic related parameters you may have to collect, maybe through the video image detectors or the loop detectors or other methods. This is the best example of a inductive loop detector in which you can get the details of the vehicle, the type of vehicle, the speed of the vehicle, the weight of the vehicle, etc., etc. All those things you can get it. This is a mechanism. Conventionally, we were following that one, keeping the detective loops on the highways or the roadway, and that will be connected to a control system where it will be collected. And you can see the way how that loop system is embedded. It will be installed in a road system, and above that when the payment layers are coming. So that's the way. Or it is also possible to get that the details through the other detectors, for example, installed above or adjacent travel way, or technologies like microwave radar, infrared, ultrasonic, acoustic, or video image vehicle detection. All those methods we can use. You can do that one. You can use this technology to get the data. And or you may sometimes you can use this the systems like the collection mechanisms through which it can be mounted above or to the side of the road, directs beam of energy into the detection area, and you can see the monitors both directions simultaneously or separately. The microwave radar system you can do. You can even use the infrared also. Infrared mechanism also you can use. Again, the basic concept in all these cases is you have to get the image or the some signal from these vehicles, so that the system can identify the type of vehicle, the speed of the vehicle, then maybe sometimes the weight, or sometimes the other parameters, including even the driver behavior also, you will be in a person to get it. So mounted overhead or side, like I said, you can do that one, susceptible to but environmental conditions. So that is one difficulty. Maybe in the rainy season and all, you may have to give more care to that one. You can even use ultrasonic mechanisms like the figure shown here. At the cone of influence, whatever the objects that is coming in that cone, it will be recognized, and the ultrasonic sound wave signals you can collect, and it can be processed. So even the sound is also signals also we can use acoustic technology through which you can use the microphone and the signal processing technology to listen for sounds and identify the source of the signal, the type of the signal, then classification of the parameters which you are looking for. So that is also possible. And now this is very common, in which you can get the video-based vehicle detection systems. Even the online facilities are also available. It will be installed at an elevated place, and you can see that one. It can be the video image will be coming. Even the classified volume also you can get almost 85 to 90% accuracy. You will get this data and that data can be used for the planning of the transportation system. So the video-based vehicle monitoring system is also possible. Or you can even use the automated like a vehicle identification system, AVI system. Maybe the gantry systems can be there, and this the antennas can be fixed there, and there can be connected to the reader, and there can be the recording mechanism also can be there. And this is the like an important one in which you have the automatic vehicle location system. Now, earlier, maybe online or like at locations, we were keeping all these equipments or instruments to collect the details. But now that the concept has gone beyond that one in such a way that any or the all moving vehicles on the street system will be in a position to collect the data, or the position of the data, the vehicle itself will be communicated to the central system, and each and every vehicle's details will be getting, and it can be analyzed automatically, and you can use that data for the planning purpose. So the automatic vehicle location system, in which you may use GPS satellites, or you may use a radio system, and or the roadside like information systems are possible. And this was the very first concept which we used at the beginning, where which GPS-based vehicle tracking system, and now that it is very common in almost all heavy vehicles, even in like Kerala, it is there. The tracking systems are available, and that is the way how we were in a position to like monitor or like investigate the the accidents. For example, Avinashi accident, the authorities could get the details of the speed of the vehicle and where it was stopped, and how much the time they were like stopped, and which locations. All those things we could locate. So the vehicle GPS-based vehicle tracking systems are available, and it will be communicated to through a central system through detectors, like transferred to the transport center, and it can be stationary or mobile communication media, or again, as all of you know, the cost of communication increases with the bandwidth. And this is giving a graphical representation of the data communication, the cellular system. You can see that one. Maybe the towers are there, buildings are there, vehicles are there, then signal systems are there at the intersections, and all those things will give you the data. And finally, the data processing, even you can collect the data, analyze the data, keep the listener, you can record the data, you can update the data, you can analyze the data, including the latest technologies like a decision support system, or a lot of applications are coming in the areas of artificial intelligence, or maybe the machine learning systems, and all these data can be used, so that in some cases, even every second or every 5 seconds, the things will be updated, even that can be used for the communication purpose. So then finally the information is conveyed to the users through the telephone, radios, televisions, and the computers. So the mobile terminals like car radios, cellular phones, laptops, internet, car-mounted computers, pages, etc., through which you can disseminate this information. Okay, through different like the medias, or the sources, through the sources you can disseminate this details to the users. Coming to the ITS functional system, of course, these are all conventional ITS information system, in which advanced traffic management system ATMS is there, advanced travel information system ATIS, commercial vehicle operations are there, CVO, advanced vehicle control systems are there, advanced public transport systems are there, advanced rural transportation systems are there. All together, these are all coming under the main umbrella or the cover intelligent transport system. And these the sections, they have further subsections are there, and even the developments are taking place. Now we'll be discussing some of the important or very popular the applications. The figure shows, the slide shows the traffic management system. You can see that one a control system. It can be connected to the signal control. It can connect to a RAM metering. It can connect that one to a video surveillance CCTV system. It can connect that one to an electronic toll collection, or it can be connected to a variable message and VMS. It can connect that one to a parking guidance, or it can even connect that one to the environmental monitoring, and it can be connected to the public transportation system. And the traffic management, online, the details will be communicated to the road users, maybe the bus passengers, or maybe the car users, or the two-wheeler, or maybe a person who is planning for a travel from one origin to one destination. So what are the available the modes that is available? What is the congestion situation? What is the route which he can select? What is the climate conditions? The possibility of parking his own vehicle? All those details you can get it from the traffic management system. And there will be a centralized management system in which you can monitor the movements of this traffic, or the efficiency of the traffic systems in the entire city, or maybe a sector, or a zone. You can do that one from the center itself. You can do that one with the traffic management system. There again, you can see that one, especially in the case of intersections and all. You can see that one, the signal control systems are there, and it will be connected maybe between the signals, or the area coverage will be there, or the corridor management is possible, and this can be possible. The traffic management, maybe the intersection. It is possible even to do the parking management, isn't that the availability of parking slots, or you can even think of you can book the parking your requirement in advance, so that a slot will be available to the road user. Then another the operational system is the electronic payment. That is it is become very popular now in all the sectors, even including the transportation sector. Also, you can have the electronic payment, reduce the cash handling cost for transit operators, more accurate data collection, convenient for the passengers, no need to carry extra change for fare payment. These are all some of the examples in which you can see that one, the toll collection through the electronic toll payment, electronic road pricing. This is the case in the case of in Singapore, where you can see the first photo in which ERP is in operation, and it is not in operation, so that message will go, and the ERP automatically the price will be collected from the card, or you may get the information. You can get the information directly through this variable message signs, or the VMS. You can see reduce speed, the construction ahead, or you can have other options like accident, congestion, like ice, snow, etc., etc. So this will be informed to the road users in advance, so that the road user will be in a position to change his route, or his the mode of time. All those things here are possible. Then benefits of the advanced travel informations include the reduced incoming, especially for the public transport services, reduced incoming phone calls seeking transit information, transit transportation service, public transport system, shorter phone calls, fewer drop calls, increased ridership from new and existing patrons, increased customer satisfaction, less email correspondence, and faster access to service information when researching problem. This is the best example of the travel time displays. Now you will get that your travel information in your mobile, maybe through your Google or other mechanism. But this was the one which was the beginning again in Singapore, in which you can see the time required to reach that destination. It will be displayed in advance. That is possible based on the speed of the traffic stream, the distance, and the traffic conditions there. Fine. So the VMS are useful to convey the weather condition, congestion conditions, or the pedestrians in the roadway, closed roadways, or sometimes the construction activities, etc. And you can have even the transit information systems also, maybe through interactive voice response, data cables or interactive maps on the web, tables or the interactive maps on the web, dynamic message signs, instant message to cell phones, or personal digital assistants. All those things are possible. The informations will be coming. Even you can get that one even in the map, or even it can be displayed the destination, when the next vehicle is coming, or the timetable, or the location of the current vehicle. This is possible. Probably you can expect that one even in India, in Kerala, in the near future, maybe in maybe 3 to 4 months. The KSRTC is planning to have that tracking system and display that to the users. Or the mass rapid transit system, where you have the metro or other facilities in which the network and even the timing for the next train. These are all very common nowadays in all metro network. You have the automatic vehicle location I already mentioned, in which you have a GPS, and maybe that details will be going to the main center location. You can even have the automatic passenger counter. Sometimes you may require the ridership information. This is possible. You have the passenger count, the mechanism you can install at the bus stop, so that let's say now how many passengers are boarded are automatically they will count the board and elate details of these passengers, and increasing the amount and quality of the data collected is possible. Even this is another area where you can have that ITS application, where the transit signal priority. A bus is approaching an intersection, that bus will be getting that green signal priority will be given to the bus, maybe, so that the travel time in a bus will be less than that of a private vehicle, maybe in the form of a car or a two-wheeler. So when you are getting this bus priority or the transit signal priority, it will be easy to cross that intersection without any delay. Maybe this is applicable even in the case of emergency vehicles also. That is now that we are using that. Then smart card based fare system. You need not use the cash. You need not give that exact changes, etc. and all. You can use your smart card, and that can be shared. That can be used to pay that fare. And that is the advantage that is coming is you can use that one for multi-modal systems, which is going to become a reality, and we are introduced that one in Kerala, Kerala, even in Cochin. You know that one, the train, bus, auto rickshaws, taxis, water transport, everything is integrated together, and you can use one unified a card system, and this will be used for the origin to destination. Only one fare will be there. Okay, so such smart card systems you can use. These are all. This is one used in Singapore. Easy link. It can be used to the bus, the train, or even to take a photocopy. Also, you can do that one. and it will be monitored. The city traffic will be monitored at an individual transport system center. So also possible. So the onboard safety and security mechanisms are also the facilities are also available. I may show some examples. For example, incident response, in which a detection, assessment, or response or evacuation or communications, especially in the centralized systems and all, when you are monitoring that one, if all of a sudden in a heavy traffic corridor, the traffic is not coming, then in that case you can expect that one some incident happen, and it can be it can be assessed or it can be detected even by sitting at the centralized place, and accordingly the evacuation or the response activities you can do. It can be communicated to the other road users and all. This is another example in which dynamic message signs alert travelers on accidents, stalled vehicles on the vehicle on the road ahead. It can be communicated through the communication systems, the incident and the accidents, etc. And you can show the advanced warnings like the fog, use lights, or the rain, the slippery roads, etc. Even there are lessons now that smart car or the vehicle systems are available in such a way that it will be monitoring the driver facial the changes, maybe sleeping or drowsiness, etc. can be identified through this vehicle facial detection system. The automatic driving, automated cars are coming. Now that maybe it will be available for the road users. Beyond that one, you can see that one, the night vision, like when in the headlight, probably the people, the crossing may not be visible to the driver. Night vision, pedestrian detection is also possible. Facilities are available to identify these objects, moving or stationary objects. It is also possible to identify the speed limits automatically. The vehicle will control the speed, or like the safety parking assistance systems is possible. Pollution detections, you can see that one. Safe surrounding will be created. A virtual this one is possible. So these are all automated highway systems are also coming. The spacing between two vehicles and the safe distance, the safety aspects are also coming. It is also possible to identify the steering assistance, whether you are following the lane or you are deviating from the main lane, or whether it is understeer or oversteer. The such detections will be there, so that it will be informed to the driver well in advance in such a way that he can be alerted, he can be sensitized, and accordingly the safety precautions can be there. So these are all the advanced vehicle safety systems, like blind spot detection system, lane departure warning system I have shown you, enhanced visibility, especially in the night time or the poor visibility conditions, rear view camera, reverse backup sensors, automatic braking, forward collision avoidance system. This is the forward, I have shown you the forward collision avoidance system, then a side view assist and similar example. Okay, and I mentioned that one, that it is possible. You have a lot of applications in the transit systems, advanced warning of impending mechanical and electrical failures, integrated single point operator sign-on of various onboard systems, management of onboard devices, maybe the petrol, the air condition of the tire. All those things are possible. This I have seen in which alcohol interlocks. Recently I visited Taiwan. I have seen that one. All the taxi driveways, you have the system in which the taxi driver can switch on his vehicle only after checking the presence of alcohol. So this is a lock system in which alcohol detection is possible, so that like the safety can be improved. And other technologies you can support to safe driving is smart license car key, alcohol interlocks, drowsiness alerting systems, seat belt reminder system, personal navigation devices, intelligent speed adaptation, point-to-point speed enforcement, variable speed limit signs, driver workload management, enhanced night vision, illuminated road studs, and protection for pedestrians and cyclists at a crossing. These are all like possible the driving safe driving systems, and it is already implemented in even in including Indian condition. Collision warning system, lane and road departure warning system, vehicle activated warning system, tracked activated speed advice system. Like that, listener, you can have all those things. And other ideas in Indian vehicles are brake assistance, adaptive cruise control, emergency crash assistance system, and the railway crossing assistance system. So this is one figure photo showing the advanced driver assistance system, and different parameters are there, how it is interconnected, and this is the architecture. I'm not going to the details of that one. And it's also possible that advanced driver assistance systems are also possible, especially I mentioned that lesson pedestrian crossing or intersection crossing, or the speed or other like restrictions or the visibility restrictions, etc. It's coming. Okay, and this I mentioned that face detection sensors are available. You can monitor the the driver and how alert he is and his behavior, and it is implemented in the commercial vehicles also in Indian condition, even in Kerala, but still it has to go a long way to monitor that one, take the data, and we have to process that one, we have to analyze that one, and we have to correct the mechanism. Okay, so such a drowsiness information system like image processing techniques are available, so that let's say the driver will be monitored. So this is the driving assistance in the case of night vision. You can see that on low beam range, high beam range, so that night vision lets the objects or the pedestrians or the vehicles or other these things, you can see that. Okay, and this is a driver assistance navigation support in which you can control the speed, you can see the situations or the environment around that vehicle, or in front of your the vehicle, etc. And the NPR cameras, all of you know, like automatic number plate reader systems are available, so that this can be used for the violation of the speed or violation of the signal, and maybe the informations it can be collected through the control system, and then to the through the VMS. This is the interconnected the vehicle. The vehicles around you also will be connected through your communication systems available in the vehicle, so that the connected cars will improve the safety of the vehicle. And this is the vehicle to vehicle or vehicle to infrastructure connected cars. You can see the vehicle is moving, and the safe distance or extended safe distance. Then the details will be connected to the vehicle, or maybe to the roadside equipment, or infrastructure-based warning systems possible. Lane support is possible, whether he is deviating the lane, or the collision, like at that speed, let's know what is the safe distance he is available in front of him, or the rear detection or the blind spot, etc. also is possible. Okay, and finally, maybe in the near future, this is the the technology which we are expecting in such a way that the driverless cars will be coming. Okay, I will skip all those things. The conclusion is, I just wanted to mention that the ITS is for sustainable transportation development, aiming at efficient, comfortable, economical, safe, pollution-free, and the tension-free. So ITS is towards safer, quicker travel. Thank you.
Participants, if you have any questions, you can put it in chat box, or you can unmute and directly ask to the speaker. Sir, I have a question, sir.
Yeah.
Yeah, like how far in India this ITS system is working, or development in ITS system?
Yeah, it is. I don't know whether you have seen that item recently. The smart city, in a small way, at Cochin, we have inaugurated the ITS component there. That is restricted maybe to a limited area, like, let's say, maybe the intersection or things like that. But it is going in a large way, like the bus information system is going to come, parking management system is going to come. Then even parking management, like the fare system, all those things are also going to come. And the red light violation is now it is available. You can detect the vehicle. You need not like a police person usually is not required at the intersection. It can be automatically possible to get the number plate number, and the challan is going. Probably in the near future, maybe in a year, like this, you can expect that one, that in such a way that even in the the KSRTC buses, when it is running from one point to other point, the vehicle, the traffic violations on that route also will be identified.
Okay, fine.
Because they have fixed the camera.
Yeah. More places it
online
is there.
available.
More cameras are there, but starting it is okay, but later on the maintenance is not going on.
Like now that, let's know, that is what you said is correct. Like, let's know, you can install the camera GPS systems in different vehicles, especially the commercial vehicle. The maintenance is a big problem. Agreed.
Yeah, sir. So that is a main problem in India. If it comes also later on, the maintenance problem will be a big issue.
There can be another model, sir. Now, if you are coming under, like, let's know, in the if you introduce a private participation, like you give that work to a private agency, he will maintain that one. He will get the the revenue for the government. That is also possible. So that, let's know, he will his business will be, if he is getting the data only, he will get that business. So that way, model is possible.
Okay, fine.
Okay. So that models are coming.
Sure, in future it will come in India also.
I'm not talking about in India. I can tell you that it is coming in Kerala.
Okay, fine.
Okay. See, now that, like, let's know, one thought is, somehow we should get the revenue for the the government, no?
Government, yeah.
Okay. More you violate the traffic rules, the government will be benefited, no?
Yeah, more income will come. More fines will come.
More fines will come, and when more fines are coming, your income will be improved, and then indirectly,
and that has to be used for the development of the traffic system again.
Yes, exactly. And then naturally the number of the accidents also will reduce.
Yeah, fine.
That is more important. Traffic violations will be minimum.
Actually, this is a multidiscipline, like a computer science engineer, electronics engineer, civil engineer can together work.
Exactly. It is only with the support of electronics and computer science and IT, only this ITS will function.
Yeah.
Okay. Now, NATPAC is associated with that CDAC and CULTROD. They are the we are giving the idea, they are developing the the system.
Yeah. Okay. I think no more questions are there. So it was a wonderful session. Sir has covered different aspects, like there are different challenges for improving road safety and congestions, and ITS plays an important part or role in ensuring road safety as well as traffic congestion. So discussed various benefits of ITS architecture, techniques used in ITS, etc. So totally the entire talk was fruitful, and I believe that all participants have collected some valuable information from this webinar. So on behalf of IEEE Malabar Subsection, I thank Dr. Samson Mathew for spending 1 hour with us. So thank you, sir. Thank you, sir.
And thank you all. I could see that around 60 participants even.
Around 60 participants came.
Yeah, that's a good crowd in the evening. Very good. Yeah. And thank you for giving an opportunity to share our experience with the Malabar Center.
Okay, thank you, sir.
Special thanks to Dr. Madhu.
Yeah, sir.
Thank you.
Thank you, sir.
Thank you.
So for the participants, we have feedback link shared in the chat box. You can fill it out for enabling certificate also. So once again, on behalf of Malabar Subsection, I thank all the participants for coming over here and listening to our talk. Thank you.
Thank you. Bye.
Bye.